Today we're going to go over single phase transformers. So an example of a single phase transformer is going to be your doorbell. So what I do is I put high voltage onto the primary side and I get low voltage on the secondary side. So in that case, when I have a higher voltage going to a lower voltage, that's a step down transformer. If I could also have a step up transformer, that's where I'm going to have a lower voltage on the primary. The secondary will actually have a larger voltage. And then there is a third kind, which is an impedance, and that is whatever voltage is going in is the same voltage going out. And we're going to kind of explain how these work. So inside the transformer, there's absolutely no moving parts. I have an iron core. I have laminated iron going around with coils of wire on both sides. So I put voltage into one side. In this case, we're going to go with 120 volts. And this is important. Transformer, a single phase transformer, is only for alternating current, for AC. If I put DC into this, it's just going to burn it up. So we don't use DC on transformers. And I'll show you this in a second why. So I have 120 volts on this side, and let's say on this side I have 60 volts coming out. So what actually happens is nothing is touching here. When I put the voltage in, this creates a magnetic field around these coils. Because any alternating current going through any wire has a magnetic field. And that's going to pick up some of the magnetic field on this side and produce a voltage onto the secondary. Now nothing ever touches. It's just how much of the magnetic field it picks up. And this is actually proportional with ratios. So if I have 10 windings on this side and 5 windings on this side, that's actually 2 to 1, the ratio. So it'll be 10 over 5. And it's going to be a 2 to 1 ratio. So the windings are proportional. So if I had, let's say 300 windings on this side, and I had 10 windings on this side, that would be a 30 to 1. So those two numbers need to go together, and we have to do some math to figure some of that out. So imagine that at your utility pole. That high voltage line coming into the transformer is roughly 7,200 volts, but coming out to my house is 120 volts. So if I do the math over that, that comes out to 60 over 1. So that's a 60 over 1 transformer for the ratio. So everything would be proportional. So for every 60 windings on this side, I only have 1 winding on this side. Now realize there's more than 60 windings. There might be 6,000 windings on the left side, and 1,000 windings on the right. You got to picture, like, look at windings, and then when I say it's probably 60,000, it's a lot of windings. But everything is proportional. So I want to show you something here that don't always think that it is a 2 to 1, a 30 to 1, 60 to 1, because this transformer, I put 120 volts into one side, and I'm only getting 16 out of the other. So if I just divided that, it's going to come out to 7.5. Well, how could I have a 7.5 to 1? I can't have half a winding. So, but if I doubled it, for every 15 windings on my primary side, I have 2 windings on my secondary side. So some of the things that we have to realize when we're using the transformers. And transformers are usually rated in volt amperage. Like this is a small one, so this is going to be volt amps. Your great big ones are they're rated in kVA, and kVA stands for kilovolt amps. And remember from our Ohm's law stuff, volt amps is very, very similar to watts. Volt amps is a calculation, watts is true power. And just remember, there's the step up, the step down, and the impedance. And the reason I kind of stress in these points is it's your homework assignment. It's one of the questions. The 7200 on the left side, on the primary side, 120 on the secondary. It's also in your homework, and that is a 60 to 1. And if we have any more questions on this, we could easily discuss it in the Google chat or in the classroom. That's it.